So let's look at a trigonometric ratios question from an exam. Specifically, we're going to be looking at sort of cosine or sine rule type stuff. I do want to point out that there's something within this question which I believe you haven't been taught. For part A, you should be fine. You've got all the information, content-wise. You should have been taught everything you need for part A. That's using either cosine or sine rule, depending on how you approach it. For part B, you need to know what the area of this sector is. So this sort of segment-looking thing, you need to know what that area is. Now, I don't think you know how to calculate that kind of thing yet. So what I'll do is I will just tell you what the area of that is. So to clarify, for part B, you're going to need to find the area of the whole thing. So if I just tell you the area of that sector, then you should be able to find the area of the whole thing by just calculating the area of this triangle and adding on the sector area as I tell you what it is. So let me just check what that is. What have I got? Area of the sector is about 11.1. So let me just write that down now. Okay, so the area of this little sector here is 11.1. Okay, so this bit here that I've just poorly drawn around, that's 11.1. Okay, so keep that in mind for when you're answering part B. All you need to do is find the area of the triangle. Okay, and then part A itself is finding this angle here that I'm highlighting. Okay, to do this you're going to need to use sine rule or cosine rule. Look those up if you've forgotten what they are, and give this question a go. Pause the video now. Okay, so for this first question, there's actually probably several ways you could approach it. Using various cosine or sine rules. Perhaps you choose one particular angle or another. So let me just show you one method, the way that I would do this. Here's our triangle. Here are our points. I'm going to call them A, B, and C. And we're interested in the ABC angle. Oh, so that means when I was introducing this, I think I highlighted this part. We're actually looking for this angle here. So apologies for that. That's the angle we're looking for. I'm going to give it a name. I'm going to call it alpha. Actually, let me call it theta. That probably makes a bit more sense because it's the first angle we're naming. I'll call it theta, and I'm going to call the missing side, which we don't know, I'll call that x. Okay, so remember, sine rule tells us that the ratio of an angle to its opposing side is the same for all three pairs in a triangle. So, for instance, if I knew what x was, then I could say sine of theta divided by x will be the same as sine of 0.6 divided by 4. So if I know x, I can find theta. Problem is I don't know x. However, if I know an angle and I know two of the sides, I can find the remaining side by using cosine rule. So remember, in general, cosine rule, we've got a squared equals b squared plus c squared minus 2bc cos capital A. Okay, where in this case all that really matters is that the A side is the side which is opposite to the capital A angle. So in this case that A side must be the 4 because the only angle I know is 0.6. Okay, remember that's 0.6 radians. So we're going to have 4 squared is equal to, and then the other two sides squared, which is 5 and x. Take away 2 times those two sides. So 2 times 5 times x, that's going to be 10x, times cos of the angle which is opposite the 4 side. So the 4 sides there, and the angle opposite to that is this one, the 0.6. So let's put 0.6 there. Okay, this is a quadratic equation, so it's not quite as simple as we could have hoped for, but at least we know there's going to be a solution, hopefully. Well, there should be, right? Because as long as this construction is possible, then there will be a solution for x. So we've got 16 equals 25 plus x squared minus 10x times cos of 0.6. Now, if I put 0.6 into the calculator, cos of 0.6, I get 0.8253 and so on. Now remember, that's in radians, so you have to make sure your calculator is set to radians. If I multiply that then by 10, I've got 8.2533. Let's write that down then and be wary to include, a reasonable number of decimal places. The final answer needs 3 significant figures, so it's best to go at least 1 or 2 more than that for your intermediate calculations, so that you don't introduce a rounding error. By working with numbers that have been rounded too much. So this is 8.25336, let's say, from the calculator, times x. Okay, that's the 10 times cos of 0.6 is 8.25336, roughly. So then as a quadratic, we've got x squared minus that number, roughly speaking, plus 9 equals 0. Use your quadratic formula, or better yet, on your calculator, use the function that solves quadratic equations. Hopefully you're familiar with that. So at least on my calculator, on the menu, I go to equation and select polynomial, and then degree 2, and then I can enter the coefficients. So the coefficients are 1, minus 8.25, so on, and 9. So then when I put that in the calculator, my solutions that I get are 6.9603 and 1.293. One of these is the correct answer, one of them is the wrong one. Hopefully logic would dictate that, well, this 1.2, that's far too small, right? This is side length 5, this is side length 4, and then given this angle of 0.6 radians, remember 0.6 radians, if you want to give that some meaning, multiply by 180, divide by pi, that's about 34, 35 degrees. So realistically, there's no way this is going to be, 1.29, that's too small. It's the longest side on the diagram, so it's not 1.293, it's the 6.9603. So let's write that in. This x is approximately 6.9603. Okay, let's get rid of this working then, we don't need any more. Now let's use sine rule. So remember, we've got that sine of an angle over the opposing side is equal to sine of any other angle over its other opposing side, and we can also flip this however we want, so we can express this again but use the reciprocals of each fraction, and it's still a valid equation. In this case, I want theta, and I've got its opposing side, and we've also got 4 and its opposing angle here. So therefore, which way around is going to make the most sense? Let's say sine of theta, so sine of the angle divided by its opposing side, 6.9603, that must be equal to sine of 0.6 divided by 4. Okay, so then sine of theta must be equal to 6.9603 times sine of 0.6 divided by 4. If I stick that in the calculator, I get 0.9825. In fact, I'm going to write it here. Sine of theta equals 0.9825. Okay, So let's get rid of all this working now. This is what we've got, sine of theta equals this, and now we're going to find theta. Now here we have to be really careful because there's something we sometimes assume when we take inverse sine, which we shouldn't always assume, and that is as follows. If I do inverse sine, okay, it's true, theta is going to be in some sense an inverse sine of this, but we have to be careful because think about it. The calculator, when it does inverse sine, it only gives you one possible value. Okay, so forget theta equals, but if I do sine inverse of that, the calculator is going to give me the following number. It's going to say 1.3835 approximately, right? Radians. Is that right? Yeah, that's it. Now, that angle is not necessarily the actual answer, right? Reason being, let's look at the graph of sine, for instance. So I'm drawing my sine graph. Okay, let's see how well this goes. Oh, not so well. Hang on. So I draw my sine graph. Okay, and remember the sine graph goes on infinitely. And all we know is that we're taking the inverse of 0.98252. So that's just a little bit less than 1, which is in fact the maximum value that sine of an angle can ever take. So, imagine you've got this horizontal line, okay, and that's at 0.98252. And the calculator will only be able to give you one of the solutions, right? There are many solutions. There's this one here, there's that one there, and so on. There's also some negative ones technically. Now, you know that an angle within a triangle is not going to be more than 180 degrees, right? Or pi radians. So therefore, we can rule that out. It's not going to be it's not going to be this, because that is at a position which is, that's more than 180 degrees, right? That's more than pi. So, we can also rule this out. We can rule out these negative values here. But the x-coordinates of these two are both valid as angles of the triangle. And the thing is, the calculator is just going to give us the smallest positive one. So that's this one here. So the calculator is saying, right, this one's 1.3835. Okay. Now remember, this point here on the graph, that's at 180 degrees. That's at pi. So therefore, this point here for the second root, let me just draw an arrow, that's going to be at the following position, pi minus 1.3835. Okay, standard sort of methods. So although the calculator gives you this solution, there is another solution which makes it true that sine of that value is still 0.98252. And that is pi minus 1.3835. So let's see what that's equal to. That's, let me just shift that up. That's equal to, on the calculator, 1.758. Okay, that's pi minus 1.3835. So both of these are possible solutions to the equation sine theta equals 0.98252, which are within the range of 0 to 180 degrees, or 0 to pi radians. So how do I know which one to take? Well, think about this. This angle is quite clearly more than 90 degrees. Okay, I'm switching between degrees and radians a little bit here, which is fine. But let's put that in terms of what it means for radians. So what is 90 degrees in radians? It'll be pi over 2, right? 2 pi divided by 4. Pi over 2. So if I do pi over 2 on the calculator, that gives me 1.57, right? So, let's make a note here. This, approximately 1.57, so roughly 1.57 radians, that's 90 degrees. So then which of these two makes sense, 1.38 or 1.7? Well, this angle is more than 90 degrees, so it's clearly the 1.758 number, not this one. So therefore, we've got our answer, 1.758, okay? And the big mistake is to see an equation like this and just assume, right, if sine theta equals that number, if I take inverse sine of the number, I will get my answer. Because remember, there's technically infinite solutions to this equation. The point being that you need to pick the correct one. The infinite number of solutions is reduced to 2 possible solutions when we're talking about triangles, and then you have to reduce that further to 1 solution by considering, am I looking at an acute angle or an obtuse angle? Okay, and remember that the calculator will only give you the acute one because it will give you the smallest positive answer. Okay, hopefully that makes sense. Let's take a look then at the second question. At the second question. Okay, finding the area of the emblem. So I did already say that I'm taking the sector as 11.1. So I'm effectively changing the question so that it matches the answer. I call this the sector. The sector is 11.1. And then let's look at the triangle again. So if I bring that across. There we go. So basically the question really is, what's the area of this triangle? This is not too difficult. So the rule we're going to use here is the fact that the area of a triangle can be determined with the formula 1/2 times the multiple of 2 neighbouring sides times the sine of the angle between those 2 sides, capital A. So in this case, let's just choose appropriately. So this is the triangle area. Let's do 1/2 times, so we've got 2 sides and an angle. Yep, so you've got 5, you've got 6.9603, and you've got the angle between them, 0.6. So this is 1/2 times 5 times 6.9603 times sine of 0.6. Okay, that's equal to, let me use the calculator, 0.5 times 5 times 6.9603 times sine of 0.6, 9.8252. Okay, so then add to that the 11.1, which I've told you is the area of this extra little bit that I've excluded, this sector bit, okay, which is missing. That's 11.1, and we get a final answer of what? Let me see. Let's say roughly 20.9. Okay, and that's our final answer, 20.9. If you are interested in knowing how you would find, the area of this kind of thing, I don't think we've gone through it, but ultimately you're considering what the angle here is, where my pointer is, and if you know that angle and you know that radius, there's a formula which will quite nicely give you the area of the whole sector, and it's to do with considering what fraction of the whole circle is this thing. So perhaps you can, as a bonus, if you think you know how to get that answer, 11.1, you can give it a go. You would need to find this angle here first though. Okay, cool, alright, so there's your answer, 20.9.